All right, we're going to talk a little bit about absolute value functions. And the reason we need to talk about this now is that we can't actually do calculus with absolute value functions in their absolute value form. We have to convert them to piecewise functions. So what we're going to talk about in this video is doing that. How do we write a function that's in absolute value form and rewrite it as a piecewise function? So if you've thought about the V, we know that absolute value functions have graphs that are shapes of V's. If you think about it, those are really two different functions, the graph on the right and the graph on the left. Let's see if I can give us a picture, a quick picture here. If we're just graphing like the absolute value of X, it's gonna X-axis and Y-axis. And we know that this graph basically has the right side of the V and the left side of the V. Of course, these do go on, they don't end where I have them. But if you think about it, each one of these is a line, and this is a line with a positive slope, and this is a line with a negative slope. And so each one of these will have a separate equation, essentially a piecewise function. So we can rewrite an absolute value function to be a piecewise function. And the most basic one is this absolute value of X. And we can do this just through basic reasoning. So what happens when X is positive? So I'm going to leave a little space here to write the equation. But when X is positive, what do you get out of the absolute value function? If I put in a 4, I get out a 4. If I put in a 7.92, I get out a 7.92. So in fact, I get out exactly what I put in. So the absolute value of X is equal to just X when X is positive or 0. And what about if X is negative? Okay. So if X is negative, which would be this part of the graph over here, I'm definitely not getting itself out anymore. I put in -3, I get out +3. I put in -10.3, I get out +10.3. So what I'm really getting out is the opposite of X, the positive version. So I'm going to kind of label this right here as the opposite of. I know the negative sign often means we say negative X, but I want you to think of it in this case as the opposite of X. So what we're really saying is if we plug in a positive number, we get out itself, which is this Y equals X line. And if we plug in a negative number, we get out the opposite of itself, which is this Y equals negative X line. So again, I'm just going to add a little bit more verbiage here to kind of really illustrate what this is saying. This is saying that the absolute value, which I'm going to shorthand to abval, of a positive number is itself. And the absolute value of a negative number is its opposite. Trying to put some meaning behind those equations that we're using. And that is exactly going to be the basis of how we break every absolute value function into a piecewise function. We're going to look at what's inside and figure out when is that positive, and then the absolute value will just be equal to itself, or when is the inside negative, and then the absolute value will just be equal to its opposite. Okay. So that general idea that we've written up here is going to translate into all of the absolute value functions we want to write as piecewise functions. So I have a set of instructions here, which I'm going to encourage you to read. Maybe just press pause on the video and go ahead and read these for a few minutes. I'm going to skip over to an example and kind of show you how to do it. And then we can go back and reread the instructions again. Sometimes it's really helpful to read them, do an example, and then reread them for added clarity. So take a minute, press pause, read what we have here, and then we're going to skip to the example. So our example says, write this function as a piecewise function and then graph it. So remember in the instructions, this +2 right here, it's outside of the absolute value. We don't care about this in the process of breaking this up. Okay, we're just going to tack the +2 on to the end of the two pieces we have. What we're really interested in is this absolute value. And the first step is to find the breakpoint. When does this absolute value function change from positive to negative? And we find that by setting the inside of the absolute value equal to 0. And then we solve. So in this case, it would be at x equals 2/3. That is going to be when this absolute value is equal to 0, which is basically the point of our v, the vertex of our v. Okay. So the next thing we want to do is just check, when is this function positive and negative? Or sorry, when is the inside of this positive and negative? So I'm just going to make a quick chart, and I'm going to have I marked my 0, my x value where it's 0. So I'm going to test something on this side, like maybe 5. Plug it into 3x plus 2. That's definitely going to give me a positive number. And then I'm going to plug in something less than that, like 0. Again, I'm plugging it in just directly to this 3x plus 2, and that would give me a negative. So what this chart is telling me is that for x values that are larger than 2/3, 3x minus 2 is positive. And for x values that are less than 2/3, 3x minus 2 is negative. And that matters because when we go to write h of x as a piecewise function, we're going to start by saying, well, this absolute value is equal to just itself. So 3x minus 2 in the place where the values are positive. So I will have just a plain old 3x minus 2, and then I'm going to tack on the extra part that was outside of the absolute value. And this is for x is greater than or equal to 2/3, this region here, because that was where the things inside the absolute value are positive. So the absolute value is equal to just itself, which is obviously I can cancel those 2's. So then in those x values where x is less than 2/3, the stuff that I'm plugging into the absolute value is negative. So the absolute value will be equal to the opposite. Just the part that's inside the absolute value will be equal to the opposite of itself. And then again, I'll tack on the +2, which was outside, so it doesn't change. And now I have my equation written in a piecewise form. Of course, I could have simplified, so this could have been just a plain old 3x. Let's see, this would have been negative 3x plus 4. And then, of course, we could graph that. I don't exactly know where 2/3 is. Maybe if I, made my x values be more spaced out. But my y values, I'm going to leave how they are because they are pretty, if the 3x, that's a pretty high slope. So when x is 2/3, which would be here, then that is going to give me, sorry, 2/3. I plug that in here, I would get 2. And then I'm going to go up from there. It's going to have on the right side, it's just going to be good old 3 times x, so 3. And then by the time I get to 2, it'll be up here at 6. Oops, did I count that right? 1, 2, 3, 4, 5. No, I did not. So I'm going to have a graph that does something like this on this side, and we would expect it to have the same slope on the other side. So negative 3x plus 4, again, just checking. If I plug in 2/3 times negative 3, that would mean negative 2 plus 4 is 2. So it lines up in that same spot. And then it's just going to have a slope of negative 3. 1, 2, 3. I can easily plug in 0 there. And negative 1. So it's going to be something like that for my V shape. So take a minute to just go back to these instructions that we had on the previous page and reread what we did. Okay, we took the expression inside the absolute value and set it equal to 0. That gave us that breakpoint, the point where the equation is going to change. That's what a breakpoint is. Then we made a sign chart. We put the breakpoint on the number line with a 0 over it, and then we plugged in something on either side of that breakpoint and recorded the sign, the positive or the negative, above the interval. So that told us when the inside of the absolute value was positive and negative. And then we just use those positives to say that the absolute value is equal to itself, which means you're basically, in that case, just dropping the absolute values. And then in the places where it was equal to a negative, we used the opposite of the original. And of course, in both cases, we're not including absolute value symbols anymore because we have now rewritten it to be an entirely piecewise function without any absolute values. Okay. So this is going to be a very critical process. It's not complicated, but you need to be able to do it. So I would suggest you take a few minutes after this video is over and go through these 4 examples here and at least just convert them to piecewise functions. You could also graph them if you want to just get a little practice at doing that because we don't really have any practice in our derivative for these absolute value problems.